Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 6 video on the chapter of cubes and cube roots, where I will solve the first sample test paper on the chapter of cubes and cube roots. This test paper will have 14 multiple choice questions, and you have to solve it in 1 hour or 60 minutes. That is approximately 4 to 5 minutes per question. If you have not watched the theoretical videos, that is part 1 to part 5 on this chapter of cubes and cube roots, then I strongly and highly suggest that you watch those videos also to have a good understanding of the chapter concepts. And always try to solve the test paper yourself first, and if you fail to attempt any question after multiple if you fail to solve any question after multiple attempts, then you see my solution video. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the sample test paper 1, the chapter of cubes and cube roots. Okay, so I have my sample test paper 1 problems on the left hand side, and on the right hand side I will solve the problems. So let me quickly check if everything is visible or not. I hope you can read the question paper properly, and it is the fonts are big enough so that you can read the questions properly. Okay, so ideally, this question paper should be solved in 60 minutes, but for I may take more than 60 minutes, because I have to, while solving the problems, I will have to discuss the concepts applied. So let's start solving the problems. So while I will solve the problems, you can pause the video and take a screenshot of the solution for your future reference. Okay, the first problem says that if x by y is a proper fraction, then which of the following is not necessarily true? It is given that x by y is a proper fraction. X by y is a proper fraction. It means that x by y is less than 1, as we know that in a proper fraction the numerator is less than the denominator, as x is less than y, less than y. Okay, so x by y is a proper fraction, and which of the following is not necessarily true? That means that we have to select the choice which is not which will always not be true, which will not always be true. That will be the correct choice. Okay, now what is the let's see the choices one by one. Choice A is given that x by y whole square is less than x by y, and this is a property we know. For a proper fraction, x by y whole square is always less than x by y. This is always true. This is always true, as we know this from a property of square. I have already discussed this in my theoretical video when related to squares and square roots. So this will always be true for a proper fraction. We know that it is always true that x by y, for a proper fraction x by y, the square of x by y will always be less than x by y. That is, the square of a proper fraction is always less than the proper fraction. So this is always true. So this cannot be the choice, because we have to select that choice which will not always be true. It may be true for some cases, but it will not always be true. Okay. What is B? What is choice B saying? Choice B is saying that x by y cube is less than x by y. This is also always true. If x is less than y, if x by y is a proper fraction, then x by y cube will always be less than x by y. Now the proof of these two properties, that is x by y whole square less than x by y and x by y whole cube less than x by y, I will not discuss this in this video. I will try to discuss this in some separate video. But know that it is a fact. It is always true that for a proper fraction, the square of a proper fraction is always less than the proper fraction, and also the cube of a proper fraction is always less than the proper fraction. So A and B are always true. The C is saying that cube root of x by y and this whole square is equal to square root of cube of x by y. Now, one concept you must be knowing, or you must know, or if you do not know, please know this fact that regarding the chapter square roots, regarding the roots, we have studied square roots and cube roots. So we know that this is square root of x. Now, a root, we have studied square root and cube roots. Now, the root can be of any integer. This is the general notation of nth root of the number x. Nth root of a number x. So for cube root, we write the 3 on the left top corner of the square root. This is cube root. If instead of 3 for square root we do not write 2, that is default. If 2 is not written, then we mean that it is a square root, that is square root. And for cube root, anything other than square root, any other root of nth root, where n is any other integer other than 2, then we have to write that number on the top left corner. So for cube root we write 3. For fourth root we write like this. For fifth root we write like this. So for nth root we write the square root of x and then we write the n. Now what this actually is means nth root, this is nothing but x raised to the power 1 by n. Now definitely n is not 0. N is a for positive integers, that is natural numbers, the nth root, this is the nth root, this thing is equal to nothing but x to the power 1 by n. You should always remember this. So definitely we can say that square root of x is nothing but x to the power 1 by 2, and cube root of x is also equal to x to the power 1 by 3. Even though you have studied exponents in your previous class 7, where the powers of the exponent or the indices were integers, but in class 8 there is also a chapter exponents where you will learn possibly regarding the exponents where the power or the exponent will be rational numbers. But since I have not covered the exponents, I have not started the chapter exponents of class 8. So this is a little bit of information before even discussing the exponents of class 8. Okay. So now once we are clear about this fact that square root of x is nothing but x to the power 1 by 2 and cube root of x is nothing but x to the power 1 by 3, let's apply this concept to solve this problem. Not solve this problem, but to see whether the option C is correct or not. So LHS, if C for LHS, not LHS actually, let's say what is this? What is this? This is first of all a cube root of x. Cube root of x we can write as x by y raised to the power 1 by 3, and we are having square of cube root of x, so we have this, and the right hand side of the equality sign, it is a square root of x by y x by y. Inside the square root we have x by y cube, and we have its square root. So this will be power half. Now for the this is equal to, again, will be x by y raised to the power, the two powers 1 by 3 and 2 gets multiplied, which becomes 2 by 3, and this thing we have the two powers 3 and half gets multiplied, so x by y 3 by 2. The concept is that x to the power, where definitely x is some rational number, non-zero rational number, to the power m, and that whole raised to the power n is equal to x to the power m into n, where m and n are rational numbers. But in class 7 you have studied these laws of exponent, where the m and n were integers. But in class 8 maybe you have already studied the exponents, the powers can be rational numbers. In general, the laws of exponents, the power or the index or the exponent is any rational number. Okay, so definitely now we can see that the two powers on the left hand side is 2 by 3, the base are the same, x by y, but the power on the left hand side is 2 by 3 and the power on the right hand side is 3 by 2. So this cannot be true. This cannot be true. This cannot be true. This can only be true only when x by y is 1. This is true only when x by y is the rational number x by y is 1. So it is not always true. It is not always true, and we have to. The problem says we have to select the choice which is not necessarily true. That is, which is not always true. So this is the correct choice. Now definitely C is not always true, so we can right away say that the answer is C, even though we have not seen what is choice D. Now if you see choice D, let's see what is choice D. Choice D is saying that y by x square is greater than y by x. Now why is this so? It was given that x by y is a proper fraction. This means that x by y is less than 1. If x by y is less than 1, then definitely its reciprocal x by 1 is less than, if x by y is less than 1, this implies that the reciprocal of x by y, that is y by x, will be greater than 1. Now if this is so, if y by x is greater than 1, then y by xx whole square will be greater than y by x. This is also a true, you can say a property which is always true. Now the proof of this property, that is A, B and D, I will try to provide the proof in a separate video, because I am not yet ready with the proof, but this is always true. So problem 1, the correct choice is answer C. C is not always true. C is only true, or will be true only when x by y is equal to 1, because 1 to the power anything, 1 to the power anything, 1 to the power any power m is always equal to 1. Okay, let's do problem number 2. Okay, problem number 2. The unit digit of cube of 517 and plus cube of 114 is. So we have to find the unit digit of what. So this number that is cube of 517 plus cube of 144. Whatever this number is, that number's unit digit we have to find. Now, if we know somehow the unit digit of 500 cube of 517, let's say, let's say, let's say, uh, let's say, let unit digit of this of 507 cube of 517, let unit digit, we are just assuming, let unit digit be let's say m, and for this 144 cube of 144, let unit digit be n. Therefore we can say that therefore we can say the required unit digit, the unit digit will be equal to unit digit of m plus n. So if the unit digit of cube of 517 is m, then and the unit digit of the cube of 114 is n, then definitely the unit digit of their sum has to be the unit digit of m plus n, because so 517 cube of 517 will be something, will be some digits, and then we are assuming m, and if 144 cube, whatever that number will be, it will be something, and it will end with n as per our assumption. Now if you add them, definitely the unit digits over here, let's say x definitely will depend on will be the unit digits of m plus n, because we always add the numbers from right to left. So we have to add m plus n, and the unit digits of the m plus n will be the unit digits of the sum of these cubes. So now the problem is, how do we know m and n? We know that so what will be the unit digit of 7? So what will be the unit digit of 517 cube? M. So m will be equal to uh, so if you see yeah, so 517 is ending with the digit 7. So 517 if you multiply it twice, definitely after these the result will be the unit digit of 517 multiplied by 517 will be 9, because 7 into 7 is 49. So the unit digits of 517 multiplied by 517 will be 9. Okay, and there will be some number over here. Now again, if I multiply by 517, there will be some numbers, and the result, the unit digits of the result will be 9 into 7 is 63. So this will be 3 and some numbers. So the unit digit of 517 cube will be 3. So m will be 3. M will be 3. M will be 3. Similarly, for 114 cube, how do we find the n? That is the unit digit of cube of 114. So if you multiply 114 into 114, then you will have some numbers. Obviously, the unit digit of 114 multiplied by 114 will be 16, because of the ending digits of 114 is 4. So 4 will be multiplied with 4, and we will have the unit digit as 6. 4 into 4 is 16, so unit digit is 6. So the unit digit of 144 multiplied by 144 will be 6. Okay, and there will be some digits over here. And when we again multiplied by 144, then obviously the units digit will be 4, because 6 into 4 is 24. So the unit digits will be 4 and there will be some digits. So ultimately the unit digits of a cube of 144 will be 4. Now m plus n is equal to 3 plus 4 is equal to 7. Hence 7. So this implies the unit digit of of given sum is equal to 7. So the correct choice is C. Okay, let's do problem number 3. Okay, problem number 3 says that a number p ends with n zeros. Okay, a number p ends with n zeros. That is, there are n number of zeros. N is some constant or some unknown. N number of zeros at the end. So, which means that p is something, a number where x are some digits, and we have n zeros. It is ending with some zeros. So we can see there are n times zeros at the end. Okay, then the number p square plus p cube will end with how many zeros? Okay, so p is ending with n zeros. So we, at the end of p, whatever the number p is, the number of zeros at the end, that is on the right hand side, is n. Now, so how many zeros will be there in p square? So this implies that p square will end with how many zeros? See, so if a number is if the number is let's say if a number ends with 1 0, let's say the number is 10, or not 10, any, let's say a number is a b c d, where a b c d are some integers and we are having 0. Now this implies that a b c d, that number, and 0 ending with 0 square will obviously end with 2 zeros. And before, to the left hand side of zeros, we will have some other digits. So the concept is that if a number ends with 1 0, its square will end with 2 zeros. If a number ends with 2 zeros, its square will end with 4 zeros. So if a number ends with n zeros, its square will end with 2n zeros. End with 2n number of zeros, as it is given that the number p is ending with n zeros. So p square will end with 2n zeros. Similarly, we can say that p cube will end with 3n zeros. The 2n zero is coming from the fact that the p square, the power is 2, and 3n zeros is coming from the fact that p cube, the power is 3. So we know that p square, whatever the number will be, p square will end with 2n zeros, and p cube will end with 3n zeros. So definitely 3n is greater than 2n. So how many zeros will be at the how many zeros the p square plus p3 p cube will end? So p square will be something like, there will be some digits, and we have some zeros, p square, and this is 2n times, and p cube is will be some number. These are some digits, and it is ending with uh, zeros, which is 3 and zeros. It is ending with 3 and zeros. It's ending with 3 and zeros. Now, for the number p square, it is ending with 2 and zeros, and before the 2 and zeros, no digit is zero. All the digits to the left hand side of the ending zeros are some non-zero digits. Similarly, for p cube, all the digits to the left hand side of the ending zeros, that is 3n ending zeros, they are non-zeros. They are some other digits. So and 3n times is definitely greater than 2n times. 3n is greater than 2n. So it will be something like, so if we add p 3 plus p square, it will be something like, let's say, not like this, let's say. So we are having p3 is equal to so p3 is equal to some digits over here, and we have 3n zeros, 3n times, and p square is x are some digits, non-zero digits, and it is ending with 2n zeros. Now just give it a thought and try to understand that p, then if we add p square plus p cube will be something obviously something like this. This x will be some digits, and definitely at the end it will have 2n zeros, 2n zeros, 2n times. These zeros will be 2n times. Why? Because if you are adding all the digits in the p square, all the digits to the left hand side of the ending zeros, which are 2n times, there are 2n zeros. They are non-zero. They are non-zero. So what I'm trying to say is that if you add two numbers, like let's say 142, and we have say 3 zeros, and if you add another number, let's say 14, so the first number is ending with 3 zeros, more number of zeros, and you are adding with another number, let's say any random number, but it is ending with lesser number of zeros, let's say 2 zeros. So if you add these two numbers, obviously the result will end in the lesser number of zeros. It will end with 2 zeros. It will end with 2 zeros. Why? So as you can see from the sum, it is obvious that since in the second number, where the number of ending zeros is less, all other digits are non-zero. So definitely, and if you add this number with the above number, that is 142000, which is having more number of ending zeros, the sum will obviously have the number of zeros which is equal to the number of zeros which is less in these two numbers. So in this case, this number was ending with 3 zeros, and this number was ending with 2 zeros, and so their sum will end with that number of zeros which is between 3 and 2, which is less, that is 2. So this is the main concept. So over here we were having p square is ending with 2n zeros, and p cube is ending with 3n zeros, and 2n is less than 3n. Obviously 2n is less than 3n, where n is a natural number. will end the natural number. So obviously p square plus p cube will end with 2n zeros, as 2n is less than 3. So as 2n less than 3n, p cube plus p square plus p cube will end in 2n zeros. 2n zeros. So the answer is choice C. The answer is choice C. Okay. Let's do problem number 4. So an equation is given. Okay, let's write the equation. Cube root of 0.729 plus cube root of 9261 is equal to n multiplied by 0.3. Then what is n? We have to find n. Now, for certain numbers, you must be very familiar with certain numbers with certain perfect cubes. Like 729, we can see the first cube root, inside we have a decimal number, but the decimal part is 729, and it is a perfect cube, which is a cube of 9, which is a cube of 9. Now the second cube root, that is 9261, I don't know. It must also be a perfect cube, but I don't know which number's cube is 9261. But any perfect cube, if it ends with 1, then its cube root has to end with also 1. Now what and this perfect cube, that is 9261, has 4 digits. So its cube root ideally should have 2 digits. Now 2 digits. Okay. Now what can that 2 digit be that ends with 1, whose let's say that 2 digit is let's say A1. So an A is some digit. So its cube, I'm just trying to find the cube root of 9261, even though I can easily you can easily do prime factorization. Using prime factorization, you can find the cube root. Let's apply the prime factorization instead of guessing. You can also do a little estimation. There are methods of estimating or even accurately finding the cube root of some number by just doing some guessing based on some logic. For example, for this 9261, the cube root, its cube root has to end with 1, and possibly since it is starting with 9, it can be the 21. Let me see. So 21 multiplied by 21, we have 21 and we have 42. So we have 441 is the square of 21, and if we again multiply by 21, what do we get? We have 441 and we get 2, 8 and 8, and this is 1 and this is 6 to 9, 9261. Okay, so 21 must be the cube root of 9261. So I was just trying to guess. So using this kind of guessing, you can also find the cube root, but a definite sure shot way is to find the cube root by prime factorization. Okay, so now I can see that, okay, so this implies that the cube root of a decimal number, if the cube root of a decimal number, it is we always try to convert the decimal number as a fraction. So this will be 729 divided by 1000. Since the decimal number 0.729, the decimal places is 3, 729, it will be 0.729 is equal to 729 divided by 1000. And this we have already found. So this was 9261 is 21 cube. This is given as n into 0.3. Now this implies the cube root of a decimal of a fraction or a rational number, we can where in the rational number or the fraction both the numerator and the denominator are perfect cube. 729 we know it is a perfect cube, it is a cube of 9, and 1000 it is also a perfect cube as it is a cube of 10. So we can say this is as cube root of 729 divided by cube root of 1000 plus we are having cube root of 21 cube is obviously 21. This is equal to n into 0.3. Now this implies cube root of 729 is 9, cube root of 1000 is 10. So we have 9 by 10 plus 21 equal to n into 0.3. Now this implies if you simplify 9 by 10 plus 21, it becomes 9 plus 210 divided by 10 is equal to n multiplied by 0.3. 0.3. Oh, sorry. The problem was not 9261 but 9.261. Sorry, 9.261. Okay. So this thing will not be 21 cube, but it will be as you can see. So now 9.261 is I did it wrong. 9.261 is okay. Let me do it. 9.61 is 9261 divided by 1000 and so now we can write it as cube root of 9261 divided by cube root of 1000. Now this will be cube root of 9261 is 21 we have found, so 21 by 10. So now this becomes the equation becomes uh, 9 plus 21 by 10 equal to n into 0.3. This implies 9 plus 21 is 30. 30 by 3 equals to n multiplied by 0.3. This is equal to, if we convert 0.3 is equal to 3 by 10. Now this implies you can cancel 10 from both sides, and so we are having 30 is equal to n multiplied by 3. This implies n is equal to 30 by 3, which is equal to then n is equal to 30 by 21, 9.261. We are having so n is coming out to be 10. N is coming out to be 10. 10 is not there in the choice. Let me see correctly. Let me check it again. Cube root of 0.729 is cube root of 729 by 1000. Okay, and this is cube root of 9.261 is cube root of 9261 by 1000. Okay, and so we have cube root of 729 divided by cube root of 1000 plus cube root of 9261 divided by cube root of 1000, and this is cube root of 729 is 9 and cube root of 1000 is 10. So 9 by 10 plus cube root of 9261 is 21, cube root of 1000 is 10. So 21 by 10. So we are having equals to n into 0.3. This implies 9 plus the left hand side, 9 plus 21 by 10 is equal to n into 0.3. N into 0.3. This implies 30 by 10 is equal to n into n into 0.3. 9261. I hope the cube root of 9261 is 21. 1, 6, 12. Yeah, 9261. 30 by 10 is equal to n into 0.3. N into 0.3 is n into 3 by 10. 10 cancels from both sides, and we have 30 equals to n into 3. Then obviously n is equal to 30 by 3 is 10. It should be 10. I'm not sure I'm getting answer 10, but it is not there in the choice. So I will put a question mark. I will see this, come back to this question later on. Let's move on to the next question. Okay. Question number 5. Evaluate. Okay, so we have to evaluate. Uh, Cube root of 15625 multiplied by cube root of 216, and this divided by cube root of 3375. Now what will be the cube root of? I hope since the choices are given in integers, obviously the cube roots, the numbers inside the cube roots are perfect cube. The 216, I know it is a perfect cube, it is a cube of 6, but I'm not sure about 15625 and 3375. Now 3375, since it is a perfect cube and it is ending with the digit 5, its cube root should also end with digit 5. So 3375, its cube root, can it be can it be 15? Let's see. Let's try to guess what could be the cube root of 3375. Let's see if can it be 15. So 15 multiplied by 15 is 225. 15 multiplied by 20 is 225. Okay, 225, and 225 multiplied by again 15 is how much? 25, 12, 11, and we have 2, 2, 5. This is 5, 7, 3, 3. Okay, so cube root of 3375 is 15. And what about 15625? 15625, its cube root will also end with 5. So cube root of any number, perfect cube ending with 5, also end with 5. Now 15625 is having 5 digits, so its cube root will possibly contain 2 digits. Can it be can it start with 20? Can it be 25? 25 multiplied by 25 is 625 multiplied by 25. Yes, I think it is 25. Let me see. 25 multiplied by 25 is 625. Now you must be wondering why I'm not straight away doing the prime factorization method, because for some big numbers prime factorization might take some time, and you can do just and alternatively, if you can just do a little bit of guesswork like the way I'm doing, you may also by guessing figure it out what the cube root will be. So 25 into 25 is, we know that 625. Now if you multiply again with 620 with 25, then and see what is 25 cube, it will be 25, 12, 31, and we have 10, we have this, and I can clearly see this is 15625. So this is equal to, we can say, cube root of 15625 is 25 cube. This is cube root of 216 is 6 cube, and divided by cube root of 3375 is 15 cube. So this is now equal to cube root of 25 cube is 25, cube root of 6 cube is 6, and divided by cube root of 15 cube is 15. So this is 25 multiplied by 6 divided by 15. So this is, if you cancel with 5, 3, 5, 5 and 3, 3, 2, so 10. So the answer should be 10. Answer is 10. So the result, the simplified value, the evaluated value is 10. So the correct choice is choice B. Okay. Let's solve question number 6. Solve for x. Okay, so the equation is cube root of 2 to the power x divided by 3 to the power x is equal to 8 by 27 raised to the power x minus 2 divided by 3. Okay. Now, for this kind of problems, we know that how to translate a cube root as a power. That is, we know that, and also square root as some power. That is, square root of x is x to the power 1 by 2, and cube root of x is x to the power 1 by 3. We should always keep this in mind. Now, okay. Now, on the left hand side, you can see there are inside the cube root, we are having powers of 2 and 3. And on the right hand side also, you can see it is an exponential term and the base is 8 by 27, and 8 is a power of, 8 can be represented as power of 2, and 27 can be represented as power of 3. So, the basic idea is that for solving this kind of problem, since we can see the unknown is in the power, eventually we have to convert both the terms on the left hand side and on the right hand side as an exponential term where the base will be equal. Since the power we can see is in unknown, the power x is in power, the unknown x is in power, so definitely the base has to be same, and then we can equate the powers. That is the basic idea of solving this kind of problem. Now, okay, now we can, this implies that it is given 2 to the power x divided by 3 to the power x is equal to, I can say, this is 2 cube and divided by 3 cube. 8 is 2 cube and 27 is 3 cube. So this whole raised to the power x minus 2 by 3. Now this implies cube root of, we are 2 to the power x divided by 3 to the power x, we can write it as 2 by 3 whole raised to the power x, and this is equal to, we can say, the base was 8 by 27, which we can now write it as 2 by 3. The base becomes 2 by 3 to the power 3, and the power was already x minus 2 by 3. Now this implies that we know that cube root means power 1 by 3. So the left hand side becomes 2 by, the number inside the cube root was 2 by 3 raised to the power x. And now if we want to get rid of the cube root and express it as a power, so we will have power, this whole power 1 by 3. On the right hand side becomes 2 by 3. We can see, so it's 2 by 3 raised to the power 3. The base is 2 by 3, and we are having two levels of powers. The first level, the power of in the first level is 3, and the power in the second level is x minus 2 by 3. So we will apply the concept that x to the power m whole raised to the power n is equal to x to the power mn. The two levels of powers, that is m and n, gets multiplied. So this will become 2 by 3 the raised to the power 3 multiplied by x minus 2 by 3. This implies, similarly, if I apply, so the left hand side will be 2 by 3 raised to the power x by 3, x multiplied by 1 by 3. This is equal to 2 by 3 raised to the power, the 3 in the power is 3 multiplied by x minus 2 by 3. So 3 gets cancels out, we get x minus 2. Now this implies 2 by 3 raised to the power x by 3 is equal to 2 by 3 raised to the power x minus 2. So now we can see that the base, both the terms on the equality side, both the terms LHS and RHS are exponential terms where the base are same. Base is 2 by 3. So we can now equate the power. So this will imply x by 3 is equal to x minus 2. So now this is a linear equation in x, and we can solve it like, so x is equal to 3 into x minus 2. This is in this, my machine is giving a problem. This implies x is equal to 3x minus 6. This implies, if I bring the x, all the x terms to the right hand side and all the constant terms to the left hand side, I get 6 equals to 3x minus x. This implies 6 equals to 2x, and this implies x is equal to 6 by 2, which is 3. So x is 3. So the correct choice is B. Correct choice is B. Okay, let's do problem number 7. The cube root of, okay, we are given an expression 9261 multiplied by x to the power 7 multiplied by y to the power 4, and this whole divided by x y to the power 10 and z cube. We have to find the cube root of. So if we have to find, let a equals to this. I'm sorry for my really weird handwriting. So let a equals to this given expression. We have to find cube root of a, that is the cube root of the given expression. Now before finding the cube root, let's simplify what is a. Let's first simplify what is a. Okay, so a is 9261 multiplied by x to the power 7 multiplied by y to the power 4 divided by x y to the power 10 and z cube. This will be equal to 9261 multiplied by, if we combine the powers of x, we get using this law, that x to the power m divided by x to the power n is equal to x to the power m minus n. If we apply this concept and we merge all the powers of x and all the powers of y and all the powers of z, we get x to the power 7 minus 1, that is 6, and we have y to the power 4 minus 10, that is minus 6, and we have z, 1 by z cube means z to the power minus 3. We have this. Okay, now this, now we have to find the cube root of the given expression, that is cube root of a, where we have assumed the given expression to be a. So this is equal to, now cube root of 9261 multiplied by x cube multiplied by minus x to the power 6 multiplied by y to the power minus 6 and z cube, z to the power minus 3, z to the power minus 3. Okay. Now 9261, we know that 9261 has to be a perfect cube. It will be a perfect cube. Now in the choices given, you can see uh, in the choices, in the numerator, we are having 11 and 21. So the cube root of 9261 has to be either 11 or 21. Now most likely it will be 21, because if you multiply 21 into 21, 21 multiplied by 21, the leftmost digit will be something, it will be either 4 or 5. So in that case, if we again multiply by 21, the chances are more that the leftmost digit of the 21 cube will be 9. So it will be 21. So this is cube root of 9261. I can write as 21 cube, and x cube, x to the power 6, I can write it as x square whole cube. Y to the power minus 6, we can write as y square whole to the y to the power minus 2 whole to the power cube, and z we can write it as z to the power minus 1 whole to the power cube. The idea is to, if we have some unknown variables like this inside a cube root, you always try to see if you can express the unknowns with a power 3, okay, because the power 3 will cancel out when you will take the cube root, because we know that cube root of any inside any number with the power 3 is equal to x. So now this becomes we can say this is equal to cube root of, since all the individual terms are having, all the exponential terms inside the cube root are having power of 3, I can say this is equal to 21 multiplied by x square multiplied by y to the power minus 2 multiplied by z to the power minus 1, this whole raised to the power 3, because we know that x to the power m multiplied by y to the power m multiplied by z to the power m is equal to x y z whole to the power m. So now we are having, so this will be now equal to, inside the cube root we are having some expression and its cube, that is cube of some expression. So this will be equal to 21 multiplied by x square multiplied by y to the power minus 2 multiplied by z to the power minus 1. Now if you simplify it further, this is equal to 21x square, and y to the power minus 2 is 1 by y square. So we are having y square, and also z to the power minus 1 is 1 by z. So we are having z. Let me quickly attach, quickly give my laptop to charging. It is almost discharged. Okay, so this should be the answer. This should be the cube root of the given expression, 21x square by y square z. So the correct choice is C. C is the correct choice. Okay, let's do problem number 8. It is saying that for some natural number n, if we have 1 cube plus 2 cube plus 3 cube plus up to n cube is equal to n into n plus 1 by 2 whole square, then the value of 7 cube plus 8 cube plus 9 cube plus 10 cube is a multiple of, okay. So it is given that a formula is given 1 cube plus 2 cube plus 3 cube up to n cube, that is it is the cube of sum of cube of first n natural numbers. This is equal to given as n multiplied by n plus 1 by 2 and this whole square, okay. So this is a formula given. Based on this formula, we have to find the value of 7 cube plus 8 cube plus 9 cube and 10 cube and say whether that value is a multiple of we have to find the value of 7 cube plus 8 cube plus 9 cube plus 10 cube and say uh, uh, among which of the given choices it is a multiple of. Okay. Now 7 cube plus 8 cube plus 9 cube plus 8 cube. What is 7 cube plus 8 cube plus 9 cube plus 10 cube? We do not have, if we do not have the initial cube or sum of cube of first 6 numbers, that is 1 cube, 2 cube plus 3 cube plus up to 6 cube. It is starting from 7 cube and 8 cube, 7 cube plus 8 cube plus 9 cube plus 10 cube. Okay. Now what can this be? 1 cube plus 2 cube plus 3 cube plus 10 cube. I know as per the given formula will be here n 1 cube plus 2 cube plus 3 cube plus dot 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 plus 10 cube is the sum of cube of first n natural numbers. So it will be, its value will be as per the given formula 10 multiplied by 10 plus 1 divided by 2 and its whole square. This is equal to 5. This is equal to 5 11 55 square. 55 square. Okay. Now it is, we have to find the value of this. Now we also know that, let's say the given expression, that is 7 cube plus 8 cube plus 9 cube plus 10 cube be x. Now we also know that 1 cube plus 2 cube plus 3 cube up to plus 6 cube, that is the sum of a cube of first six natural numbers will be equal to, as per the given formula, 6 into 6 plus 1 divided by 2 this whole square. This is equal to 7 3 21 square. Now therefore we can see, therefore this implies that 55 square was the value of the sum of cube of first 10 natural numbers. From that, if we subtract the sum of the value of the sum of the cube of first 6 natural numbers, we can say that 55 square minus 21 square is equal to x, which is or rather we can say that this is equal to 7 cube plus 8 cube plus 9 cube plus 10 cube, because 55 square is the value of the sum of cube of first 10 natural numbers, that is 1 cube plus 2 cube plus 3 cube plus up to 10 cube, and 21 square is the sum of cube of first 6 natural numbers, that is 1 cube plus 2 cube plus 3 cube plus up to 6 cube. So if you subtract the 1 cube plus 2 cube plus 3 cube plus up to 6 cube from the sum 1 cube plus 2 cube plus 3 cube plus up to 10 cube, we will get we will get the sum. We will get the result as 7 cube plus 8 cube plus 9 cube plus 10 cube. So 7 cube plus 8 cube plus 9 cube plus 10 cube is coming to be 55 square minus 21 square. Now 55 square minus 21 square, we know that we know the formula a square minus b square is equal to a minus b multiplied by a plus b. So using this formula, if you find 55 square minus 21 square, this will be 55 minus 21 and multiplied by 55 plus 21. This is equal to 55 minus 21 is 34 and 55 plus 21 is 76. So this is the 34 multiplied by 76 is the value of the given expression, that is 7 cube plus 8 cube plus 9 cube plus 10 cube is equal to 34 multiplied by 76. Now we have to see among the choices which one is whose multiple is this number, that is 34 multiplied by 76. Now choice A, whether 16 divides 34 multiplied by 76. 16 does not divide. 16 does not divide, that is 34 multiplied by 76 is not divisible by 16. 16 does not divide 34 multiplied by 76, so this is not a choice. It is saying that the value of 7 cube plus 8 cube plus 9 cube plus 10 cube is the multiple of whose multiple it is, that is whose multiple 34 multiplied by 76, whatever the value is, whose it is a multiple of which of the given choices. So we can see that 16 does not divide 34 multiplied by 76. So choice A is not a choice. What about choice B, 17? Now we can see that clearly 34 multiplied by 76, we can break it down as 2 multiplied by 17. 17 into 2 is 34 multiplied by 76. So 2 into 17 into 76 will obviously be divisible by 17. So 17 divides 34 multiplied by 76. So hence 34 multiplied by 76 is a multiple of 17. And obviously you can see that the C and D will not be correct, as 18 is not 18 does not divide 34 multiplied by 76. Also 12 does not divide 34 multiplied by 76. So hence the correct answer is 17. So the correct choice is B. B is the correct choice. Let's do problem number 9. Okay, so this formula you must already be knowing that it is given that a plus b whole cube, this is a standard formula, a plus b whole cube is a cube plus 3ab multiplied by a plus b and b cube. So if this formula is given, it is given that if a plus b whole cube is equal to a cube plus 3ab multiplied by a plus b cube, and it is given that cube root of x plus 1 by cube root of x is equal to 2, then we have to find the value of x plus 1 by x. Okay. So we are giving this formula. We are given this formula that a plus b whole cube is equal to a cube plus 3 into ab multiplied by a plus b cube. Using that formula, we have to find the value of x plus 1 by x, where it is given that cube root of x plus 1 by cube root of x is equal to 2. Okay, so from this, if we taking power, so we can say I can take power of cube, power of 3 on both sides, and I will get a cube root of x plus uh, 1 by cube root of x. This whole cube should be equal to 2 cube, that is, this is equal to 8. Now if I take the cube of root x, cube root of x plus 1 by cube root of x, if I take its cube and apply the formula a plus b whole cube, this will become cube root of x cube, because this is a and this is b, considering root 3x a and 1 by root 3x root 3 cube root of x. So cube root of x, considering cube root of x as a and 1 by cube root of x as b, and applying the formula a plus b whole cube, we get this plus 3 into a is cube root of x multiplied by b is 1 by cube root of x, and a plus b, uh, a is cube root of x plus b is 1 by cube root of x, and plus we have b cube, b is 1 by 1 by cube root of x, its cube. This is equal to, we are having 8. Now this implies, if we simplify the left hand side, cube root of cube root of x. Now you must be very clear about these two facts, that cube root of x cube is x. Also cube root of x, if you take its power 3 or cube of cube root of x is also equals to x. So cube of cube root of x is x plus 3 into cube root of x multiplied by 1 by cube root of x. This gets cancelled. So 3 into, we are having cube root of x plus 1 by cube root of x plus cube of 1 by cube root of x is 1 by x. This is equal to 8. Now this implies we are having x plus 1 by x plus 3 into cube root of x plus 1 by cube root of x was already given to be 2, so we have 3 into 2 equals to 8. So this implies x plus 1 by x is equal to 8 minus 6 equals to 2. So the value of x plus 1 by x is 2, and the correct choice is D. D is the correct choice. Okay, let's do problem number 10. Problem number 10 is a simplification problem. We have to simplify cube root of 16 multiplied by cube root of 500. Now whenever you are given this kind of expressions, we are having cube root of some numbers, inside the number cube root of some number which is not a perfect cube, and you have a product of 2 or more cube roots. Then apply this formula, that cube root of x multiplied by cube root multiplied with cube root of y is equal to cube root of x multiplied by y, because once you multiply x with y, that number, it can form it can be a cube of some numbers. So this is equal to I can say cube root of 16 multiplied by 500. This is equal to cube root of 16 multiplied by 500 is 16 into 5 is 80. So we are having 8,000. Now 8,000 you must be you must very easily say that 8,000 is nothing but 20 cube. Cube of 20 is 8,000. So cube of 20 is definitely 20. So the simplified value is 20. So the correct choice is B. Correct choice is B. Okay, let's do problem number 11. Okay, so one equation is given which is cube root of root x minus 1 by root x, and this multiplied by cube root of root x inside root x plus 1 by root x is equal to m. Then the value of x square plus 1 by x square is, okay, we have to find the value of x square plus 1 by x square. Now, okay, now we can see some pattern that inside the first cube root we are having root x minus 1 by root x, and inside the cube root of the second cube root we are having the expression root x plus 1 by root x. Now if you multiply root x, so these small things you must observe and then do some observation and see, that can help you how to proceed with the solving of the problem. So we can clearly see that if I multiply root x minus 1 by root x, this multiplied by root x plus 1 by root x will be equal to root x square minus 1 by root x square. This is equal to root x square of root x and squaring of 1 by root x squaring of 1 by root x is 1 by x. Now this is applying the formula that a plus b multiplied by a minus b is equal to a square minus b square. Now we can see that on the left hand side it is a product of two cube roots. So since we know that root x minus 1 by root x multiplied by root x plus 1 by root x will become x minus 1 by x, we will apply the formula that this will be left hand side will be equal to cube root of root x minus 1 by root x multiplied by root x plus 1 by root x, and we have on the right hand side m. So we applied the formula that cube root of x multiplied by cube root of y is equal to cube root of x into y. Okay, so we have this. Now the left hand side becomes cube root of, if you do the multiplication, it is in the form a minus b into a plus b, it will become, we have already seen that the product of root x minus 1 by x and root x plus 1 by x is x minus 1 by x. X minus 1 by x is equal to m. Now I will take the cube of both sides. I will get rid of the cube root by taking cube of a power of 3 on both sides. So this will be this is equal to, I can say that I can take a power of 3 on both sides, that is cube root of x minus 1 by x. I can say this power cube is equal to n cube. This implies, now you always must remember that cube root of if you take cube root of x and if you take the cube of cube root of something is something, That is, this is cube root of x. This will be equal to x. So in this problem, we will have the left hand side x minus 1 by x is equal to m cube. So we got x minus 1 by x equals to m cube, but we are asked x square plus 1 by x square. X square plus 1 by x square. Now you have to apply a little bit of knowledge, apply the formula of a plus b whole square. Now x square plus 1 by x square, from this term, from this expression, you must be you must be you must have the idea of feeling that it is coming from the squaring of x plus 1 by x. We know that x plus we know that okay, so we got x minus 1 by x equals to m. Now we can say, if we do the squaring, if I do squaring of both sides, squaring on both sides, I will get a square of x minus 1 by x is equal to m square. So sorry, x minus 1 by x was m cube, and if I do squaring, this will be m cube and then raised to the power 2. This was cube. Okay. Now this implies, if I do the squaring of left hand side a minus b, you must be familiar with the formula a plus b whole square and a minus b whole square. So a minus b whole square is equal to a square plus b square minus twice a p. So applying this formula of a minus b whole square for x minus 1 by x whole square, we get x square plus 1 by x square minus 2 into x multiplied by 1 by x is equal to, on the right hand side we have m cube and then whole raised to the power 2, it will be m to the power 6. Now the left hand side becomes x square plus 1 by x square minus the x cancels out, minus 2 is equal to m to the power 6. So this implies x square plus 1 by x square is equal to m to the power 6 plus 2. So this should be the value of x square plus 1 by x square, and the answer is correct choice is D. Correct choice is D. Okay, let's do problem number 12. Problem number 12 says, if P be a two-digit number ending with the digit 5, if P be a two-digit number ending with the digit 5, then the number formed by the ending two digits of P cube is divisible by. If P be a two-digit number ending with the digit 5, two-digit number ending with digit 5. So okay. So it is the number P is of the form A5, but A is some digit, A is some non-zero digit. Now it is saying that then the number formed by the ending two digits of P cube. Now P cube, what can P cube be? P is A5. This A5, where A is some digit, can be if I expand in the expansion form, in the expanded form, A5 will be 10A plus 5. 10A plus 5. Now this A5 is it means a two-digit number. It is the representation of the two-digit number where the digit at the units place is 5 and A is some digit, non-zero digit in the tens place. So if A5 is a two-digit number, then in the actual now value in the expansion form, in the expanded form, is 10A plus 5. 10A plus 5. So p cube will be 10a plus 5 cube. Now this is a plus b whole cube. If you apply the a plus b whole cube formula, this will be 10a cube, that is a cube, plus 3ab, that is 3 into 10a into b into 10a plus 5, and then b cube, that is 5 cube, that is 5 cube. Okay. Now 10a cube is nothing but a cube multiplied by 1000. 10a cube is equal to 10 cube multiplied by a cube, and 10 cube is 1000, so it becomes a cube into 1000, plus over here we are having 3 into 10a into 5, which is 150a, and then we have 10a plus 5. And 5 cube we have 125. We have to find the last two digits. We have to figure it out. What can the ending two digits be of p cube? Okay. So whatever the ending two digits will be, that two digits, that number found by that two digits is divisible by, we have to find that number. We have to select the choice that divides that two digit number of that two ending digits of p cube. We have to select the choice. The choices are 15, 35, 20 and 25, so that we have to select that choice which divides the number formed by the two ending digits of p cube. Now what can the two ending digits of p cube be? That we have to find. Well, now it will be difficult, at least I am not sure how to solve this problem like this algebraically, but since p is a two digit number ending with 5, the number p can, what are the possibilities of the number p be when it is given it is a two digit number ending with 5. So p can be 15, or it can be 25, or it can be 35, or it can be like this, it can be 95. These are the possibilities of a two digit number ending with 5. Now fifteen cube, 15 cube. What is 15 cube? Hmm, 25 cube. No. 95 cube. No. I was trying to think, taking some examples. So these are the possible values of p, which is a two digit number ending with the digit 5. So it could be 15, 25, 35, and considering once each of these numbers, if I try to find find its cube and see what are the two ending digits, and if I see any pattern, but it will be time consuming. Now this I will not do it. Now, so we have this formula. P cube is 1000 a cube. What can be the two digits be? Now definitely the two digits will not be determined by this, because the ending two digits of p cube cannot be determined by a cube into 1000, because a cube into 1000, that the number is having the three and the ending is ending with three zeros. So that will not determine what will be the two ending digits of p cube. 125, the last value 5 cube, that is 125, will definitely determine, will definitely uh, will definitely play a role in play a role in deciding what the two ending digits of PQ will be. Now, what about this term 150a multiplied by 10a plus 5? Now, 155, 150a multiplied by 10a plus 5 will obviously end with a 0. But what will be the digits? What will be the digits at the tens place of this term, of this value? That is 150a multiplied by 10a plus 5. So definitely we can say that this is not playing any role, this term is not playing any role in determining the two ending digits of PQ. This value will determine, because the two ending digits of 125 is 25. Now we have to somehow find what will be the two ending digits of 150a multiplied by 10a plus 5. If we can somehow find that, then those two digits plus 25, because the last two digits of 125 is 25, we can say what will be the last two ending digits of p cube. So what can we say about the last two digits of 150a and multiplied by 10a plus 5, multiplied by 10a plus 5. Now a is a digit, a is a digit, a is a digit. Now a is a digit, so 10a will obviously end with the digit 10a will end with the digit 0. Mm, uh, so 10a 10 so 10a is basically so 10a will be something like uh, let's say B0. 10a will be a is a digit, a is a single digit, so a is a single digit that multiplied by 10 will obviously be a number which will end with a 0, and it will also be a two digit number, because a is a digit, that is a is either a digit from 1 to 9, so it can only lie between it can only be 10 or 20 or 30 or 40 or 50, 60, 70, 80, 90, this 10a. So it will be of the form B0, where B is again a digit from 1 to 9. So 10a is ending with the digit 0. That plus 5, if we do plus 5, so 10a plus 5 will obviously end with the digit 5. End with the digit 5, and this will be B5, and B can be any digit from uh, B can be any digit from 1 to 9. B is any digit from 1 to 9. Okay. Again, we have 150A multiplied by 10A plus 5. 150A, the number 150A will end with the 0. No, B5. 10a plus 5, 10a plus 5, this number, whatever the number is, will end with the digit 5, that is for sure, and it will be a 2-digit number like B5, where B will be some digit from 1 to 9. Now that multiplied by 150 150 multiplied by a is a number that will end with 0. No, I don't think I can solve this problem. I'm sorry, I couldn't solve this problem. It is becoming complex. So I will skip problem number 12. So I couldn't solve the problem number 12. Sorry for this. Okay, so I couldn't solve it. Uh, Failed to solve this problem. Okay, let's move to problem number 13. Problem number 13. Problem number 13. The value of, okay, so it is given the cube root of 1 plus 3 plus 5 plus 7 plus dot 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 plus 15 is what? Okay, so the value inside the cube root is, we can see the sum of the sum of some consecutive odd integers, odd positive integers, that is 1 plus 3 plus 5 plus 7 plus up to 15. Now the last the last odd positive integer in the sum is 15. So from the last number, how do we say how many first odd positive integers are there? Always remember this fact that uh, hmm, if you are given a sum like this, 1 plus 3, that is consecutive odd integers, that is 1 plus 3 plus 5 plus 7 plus dot 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 plus k, where k will definitely be an odd positive integer k, then uh, from this sum, how can you say uh, uh, how can you say the how can you say that how can you say the value of n, where this sum is the sum of first n odd positive integers. So what I'm trying to say is that we know that 1 is sum of first odd integers. 1 plus 3 is of uh, sum of first sum of 1 is sum of first the 1 odd integers. 1 plus 3 is sum of first uh, 2 odd integers, that is we are having 2 odd integers 1 and 3. 1 plus 3 plus 5 is the sum of first 3 odd integers. So like this will be, always remember that if you are having given a sum of consecutive odd integers starting from 1 plus 3 plus 5 plus 7, and you see that the last term is k, where k will obviously be some odd integer. So this is nothing but the sum of first k plus 1 by 2 odd integers. That is, applying this concept, I can say that 1 plus 3 plus 5 plus 7 plus, let's say, plus 11 is equal to sum of first The last term is 11, so 11 plus 1 by 2, that is 6, sum of first 6 odd integers. If you see, if you count how many odd consecutive integers are there from 1 to 11, you will find there are 6 odd integers, and the 6 is coming from the fact from the last integer, from the last odd positive integer, which is 11. So 11 plus 1 by 2 is 6. So if you are given a sum of consecutive odd integers, like from starting from 1, so 1 plus 3 plus 5 plus 7 up to k, where k is the last term in the sum, then you can say how will you figure it out. This sum is the sum of first n odd positive integers. How will you find n? So that n will be k plus 1 by 2. So we can now see, back to the problem, we see that inside the cube root we are given the sum of consecutive odd positive integers, and the last term is the last term is 15. So we can say that the cube root, inside the cube root, the term that is the sum of the it is the sum of first 15, sum of first 15 plus 1 by 2 first odd integers. Inside the square root, the sum 1 plus 3 plus 5 plus 7 up to 15 is nothing but it is the sum of first 15 plus 1 by 2 odd integers. That is, it is sum of first 8 odd integers. And we know the formula that the sum of first n odd integers is n square. So this will be equal to cube root of, so the sum of, inside the cube root we are having sum of first 8 odd integers, which will be 8 square, which will be 8 square. Now 8 square, 8 can be written as 2 cube, and we are having whole square. So now this is equal to, we can write cube root of, we can write it as 2 cube. We can always interchange the powers like this: x to the power m and whole raised to the power n is equal to, we can interchange the powers, x to the power n and whole raised to the power m. So we can write it here, this is equal to 2 square and whole raised to the power cube, whole raised to the power cube. So this is equal to now cube root of 4 raised to the power cube. This is equal to 4. So the result, the value is 4, and the choice is C. The choice is C. Okay, let's do problem number 14. It is saying that difference of two, okay, it is saying that the difference of two perfect cubes, difference of two perfect cubes is 189. If the cube root of the smaller cube is 3, then the cube root of the larger cube is, if the cube root of the smaller cube is 3, then the cube root of the larger cube is, the difference of two perfect cubes. Let's say let m cube, definitely now difference of two perfect cubes is, okay, let's solve this way. So we are having so difference of two perfect cubes, so two numbers which are perfect cubes is 189. If the cube root of the smaller cube is 3, then the cube root of the larger cube is larger cube is cubes. Okay, so a cube, a perfect cube has to be a cube of some number, a cube of some. Now it is talking about perfect cubes, which means it is a natural number. So the perfect cubes, the difference of two perfect cubes, that is the two perfect cubes, both are natural numbers and which are cube, that is they are cube of some natural numbers. So let m cube be larger cube, larger perfect cube, and n cube be smaller perfect cube. So what is given? The difference of two perfect cube is 189. So definitely, since we are considering m cube to be the larger perfect cube, it is given that m cube minus n cube is equal to 189. Okay. Now it is given that if the cube root of the smaller cube, the cube root of the smaller cube, the smaller cube is n cube. Given that cube root of the smaller cube is n cube, because we have already assumed that let m cube be the larger perfect cube and n cube be the smaller perfect cube. So we will the difference of the two perfect cubes will be m cube minus n cube, which is given to be 189, and it is also given that the cube root of the smaller cube, that is the smaller perfect cube, is 3. So we must have cube root of the smaller cube perfect cube is n cube. So its cube root is given to be 3. So this implies that if I take if I cube both sides, if I take the power of 3 both sides, I get this. This is equal to 3 to the power 3 is 27. So this implies no, sorry, I'm doing it wrong. We have this. It is given that the cube root of the smaller cube, that is smaller cube means smaller perfect cube. The smaller perfect cube, as per our assumption, is n cube. So its cube root is given to be 3. Now the left hand side, in this, the left hand side, that is cube root of n cube, is definitely n. So n is given to be 3. N is given to be 3. Okay. Okay. So now we have putting the value of n in the equation m cube minus n cube equals to 189. We can say that m cube minus n we have found to be 3. So 3 cube is equal to 189. So this implies m cube is equal to 189 plus 3 cube. This is equal to 189 plus 3 cube is 27, and 189 plus 27 is 16, 11 and 2, 216. So m cube is 216. 216 we know is a perfect cube, that is a cube of 6. So this implies m cube is 6 cube. So definitely we will have m equals to 6. So the answer is choice A. So I was not able to solve only one problem, which was the problem number 12. I couldn't solve it. If I can solve it, I will give it a try one more time. If I can solve it offline, I will address the solution in some future videos. So I hope this set of problems for the sample test paper number 1 will help you to give you a good practice of applying your understanding of the concepts of cubes and cube roots to solve various kinds of problems. So these are a little harder problems than the problems we have done normally from the textbook of author R.S. Aggarwal. These are conceptual problem. This will definitely help you judge your understanding on the concepts of cubes and cube roots. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video, I will prepare the test paper, sample test paper number 2, as I always prepare 2 test papers after completing a chapter. So the next video will be sample test paper number 2, and I will solve it. So that will cover the 2 test papers on the chapter of cubes and cube roots, and after that I will keep on preparing and solving 10 good problems in the playlist Maths 8 Hot. Maths 8 Hot. Hot stands for high order thinking problems. So you should always also check out that playlist, that is Maths 8 Hot, for good problems, a set of good problems. Each set will have 10 good problems from the chapter. And after this chapter, cubes and cube roots is complete, I think the next chapter is about exponents. Uh, Let me quickly check which is the next chapter. For cubes and cube roots, we are having the chapter of playing with numbers. Playing with numbers. So we will start playing with numbers once I complete the sample test paper number 2. So thanks for watching, and until the next video, take care and bye.